guys, today I'm going to teach section 6.7. We'll be going through and doing the rectilinear motion using integration this time. So we've actually done this before using our derivatives, and now I'll show you a different approach. I would just like to remind you the order that we learned our derivatives in. We said if you start with your position function and you take the derivative, you'll get the velocity, and then if you take the next derivative, you'll get the acceleration. We said students value A's is how we remember that, and then of course we talked about the fact that if we integrate, we can go backwards. Okay, so that's going to be the basis of today's lesson. In number 2 here it says, find the position function of a particle that is moving with velocity, cosine of pi t, along a coordinate line, assuming that the position of 0 is 4. So if they want us to find the position and they present us with the velocity, you see that we just have to go back one notch. And so, of course, what we'll be doing here is using the integral. So I need to integrate the velocity function, the cosine of pi t dt. Okay, so if you look at this, this is not a definite integral. So I don't have my upper bound and my lower bound. I'll have to do the plus c thing that we talked about earlier in this chapter. Also, look at this carefully because this looks like a chain rule type thing. Therefore, this is going to be a u sub problem. So don't forget all the things that we've learned earlier this chapter. For example, the plus c, the constant thing, and then of course the u substitution. So I'm going to try to let u equal my argument, so u equal pi t. So du dt would equal pi. And then when I solve for dt, I'm looking at du over pi equals dt. So I'm setting up my u sub. Let's see what I get. So I have the cosine of u, and dt is du over pi. So I'll put my du here, and I'm going to pull that constant of pi in the denominator through. Now I'm going to integrate. So the integral of cosine we all know is the sine of u. And then since this does not have a lower and upper bound, I need to put a plus c. Okay, so hopefully you're following that just fine. And then at this point, I'm going to take the u back out of my problem. So let's put 1 over pi sine of pi t plus c. Okay, so what we found here, this is going to be the position function. So I'm going to write s of t here. This is the integral of the velocity function. So when I have this, they also provide me a condition. They tell me that when they want the position of 0, or they tell me of 0 is 4. So if I sub in a 0 for my t, the answer is 4. So let's come over here and see what that can help me do. So I'm going to write my answer to be 4. I'm going to take the 0 and sub it in for my t. So 1 over pi sine of, this would be 0, and then I have a plus c. So the sine of 0 here, should all know that at this point. Let me draw that out for you. Is 0. So 4 is equal to 0 plus c. And what I just found was my value for c. So now that I know this, I can make a better answer here. My answer would be the position function is 1 over pi sine of pi t plus 4. Okay, so the condition that they provide in this problem helped me find the constant of integration. Okay? All right, so let's move on. All right, I'm going to try to explain this slowly for you because it is important, and I can see that a lot of students will confuse what it's saying. I've discussed this with you before, the difference between total area versus net area, and that's going to be a very similar thing here with displacement and distance. I want to just throw a real-life example at you first. If you are driving from your house to ShopRite, and then you're going back home, if I ask you the distance that you traveled, the total distance would include going there and coming home. So you would add up the miles going and the miles coming home. However, your displacement, since you started at home and you ended at home, your displacement would be 0. So do you see the difference between distance and displacement? So if you look at what I'm showing you here, they're showing you that the distance has to have, again, that absolute value. It takes that negative going left, that part of it, and says, wait a second, it's still a distance, and so I need to take that into consideration and add it together. Okay, versus the displacement, that's the net again. That's just the plain old integral. Look at this notation here. When I go through, I integrate, I sub in my upper bound, I sub in my lower bound. There you go. Okay, so this lesson, don't let yourself get confused. There's really two things you have to remember. There's displacement, and then there's the total distance. The displacement is the straight plain integral. Just do the integral. Don't worry about much. And if I ask you the distance, the total distance, that's where you're going to have to worry. You're going to have to think, well, wait a minute, is there a negative region? I need to turn that positive, and so on. So integral, be careful. That's all you have to remember. Okay, so here we go. Okay, a particle moves on a coordinate line so that its velocity at time t is the function given. Part A, we're going to find the displacement. Of course, they give me my interval. And part B, they're going to ask me the distance. So there's my two things, like I said. Okay, displacement. Think. I go to ShopRite, I come home. Displacement is 0. That's the net. I just have to simply take the integral, and I'm finished. Here we go. So I take my velocity function. I'm going to integrate that from 0 to 3. When I take the integral, remember that's actually turning this into the position, so I'll evaluate my position at two different locations. So when I go through, let me just write my dt. Let's write our integral, so t to the third over 3 minus 2t squared over 2. And we're going to evaluate that from 0 to 3. Let's reduce that guy there. So let's sub in our 3. 3 to the third power is 27. 27 divided by 3 is 9. Minus 3 subbed in here, we're going to get 9. Now I'm going to sub in 0. Sub in 0. And it looks like I get a big fat 0 for that one. Okay, so the displacement for this problem is 0. Okay, now let's do part B. Now I need the distance. This time I go to ShopRite, that's a distance. I come home from ShopRite, that's another distance. I need to add that together. So the question is, do I have a negative region? So think about this. This is the velocity function. Do you remember before? This is something I taught you actually before I left. You cannot change direction unless you stop, okay? It's impossible. Even if it has to be a split second. If you're running, if you're walking, you have to stop for a split second if you're going to change direction. So what we do is we say, with this velocity, let's set this equal to 0 to see, where we stop if we stop at all. So let's do that right here. Set your velocity equal to 0 and factor out a t. Okay? You can see here that we stop at both t equals 0 and t equals 2. So now we check our interval. We're going from 0 to 3. So on my velocity line, I'm going from 0 to 3. And I stop at 0, one of my endpoints, and I stop at 2. What I need to do now is figure out if I'm positive or negative in those regions, okay? So I'm going to go through and I'm going to sub some values into this, okay? So let's sub in 1. If I sub in 1 to my velocity curve, that would be 1 minus 2, and I get a negative. So we have to watch for that. If I sub in, say, 2.5, 2.5 squared minus 2 times 2.5, that's going to get me a positive. Okay, so that's not as tricky. So what we just said is when we go through to integrate, we have to be very careful about any negative region because we're looking for the distance. So what I'm going to do is I'm going to separate my integral into a piecewise type look. I'm going to go from 0 to 2, and I'm going to go from 2 to 3. Now let me just say real quick before I fill the rest of this in, had I gotten both positives, the answer would have matched the displacement because I wouldn't have had to worry about anything. But because I get a negative, I have to be careful. Now, again, we've said this in here before. Just recently, I've actually said that in the last lesson. If you have a negative, how do you turn it positive? Well, one answer is you take the absolute value, and the other answer is take the opposite of it. Okay? So I'm going to stick a negative here to make this due to positive, and then we're good to go. Okay? We're still using the same function, so I'm going to write my t squared minus 2t dt. I'm going to add that to the other piece. Okay? So you definitely had to split this up because of the negative. I compensated right there, turning it positive, and then now all I have to do is go through and integrate this. So that's the calculus part of it. The rest of this is just tedious algebra, making sure that you don't make a silly mistake. So here we go. Let's do t to the third over 3 minus 2t squared, so that's going to be just t. Okay, so I'll divide and get rid of that 2. Stick this negative out here, and we're evaluating from 0 to 2. Over here, same integral. Okay, evaluating from 2 to 3. Okay, so then we have to start to go through and sub in our values. First we'll sub in 2, then we'll sub in 0, and so on. I'm going to have you pause the video. There's no need for you to sit here and watch me go through a number crunch. I want you to do that and see if we match. Okay, so pause the video. Okay, so hopefully you've had a chance to go through and figure out what the answer would be. My final answer is 8/3. Okay, I guess I can show you a little work here for those of you that didn't get it right. I'm just going to copy this. I have 8/3 minus 4. And then over here I have a 9 minus 9. Okay, so hopefully this will help you find a mistake in here. So in the end, again, my answer is going to be 8/3. I'm running out of board space here, so if you need to take a minute, again, pause the video and see if we can help you find your mistakes with your classmates. Okay. All right, so there we go. There's, again, part A, displacement, and part B, distance. Okay. At the bottom here, the velocity versus time curve. Okay, this is exactly what I just said to you, but we can read it again. Okay, it says, for a particle in rectilinear motion, the net signed area, so the net signed area between the velocity versus time curve and the interval represents the displacement. Okay, that's just the plain old integral. Okay, so the net signed area is the displacement. It's just the plain old integral. You just go through and do it without worrying about separating. Okay, the total area, again, between the velocity versus time curve, represents the distance traveled by the particle over that interval. And this, again, remind yourself, absolute value. Okay, so the picture here is showing you, this is not in your notes, but it's nice for you to see it once again. Okay, maybe you even want to draw this for yourself. Okay, you can see for the displacement, they're subtracting that negative. But for the distance, we need the absolute value, so they're adding it. Okay, so again, links what we just talked about. Okay, move on. This is a short lesson. We're already on our last page. Okay, find the total area between the curve and the x-axis over the interval 0 to 2. Okay, so the question is asking for the total area. So that tells me total area, I need to worry about my negative regions. So the first thing I'm going to do is think about where will my problem be negative here? So again, we could draw this picture, or we could do this algebraically. So let's do it algebraically this time. I think that we all should know that this is a parabola that opens downward, that's been moved up 1. But if I want to know where this is below the x-axis, then I need to know if it crosses the x-axis. So I'm going to set my y equal to 0. I'm going to add x squared, take the square